All right, in our first video, we remembered tangent lines. Let's go one step up to tangent parabolas. So the question is this: how do we find the tangent parabola to a function at a given value? So the picture looks like this. I got a function f of x, I got a value a, and I'd like to know the parabola that fits just perfectly into the graph of the function around x equals a. So here's how you would do it. A parabola that looks like this: a0 plus a1 x minus a to the first plus a2 x minus a squared. It's the same as our tangent line, except now I have a squared term giving me a parabola. The parabola must satisfy a few conditions. It must satisfy condition 0. If I plug in a to the parabola, I should get the same value as if I plug in a to the function, so they match at a. The next condition: the derivatives have to match, just like the tangent line. But the new condition is condition 2. I'm going to also require that the second derivatives match at a, so they have the same concavity at a. We have three unknowns: a0, a1, and a2, and we have three equations: equation 0, 1, and 2. So equation 0 will help me find a0, equation 1 find a1, and equation 2 will find a2. All right, let's do an example. Let's find the parabola tangent to the graph of, let's do 1 over x at x equals 1. So here's my answer. My parabola looks like a0 plus a1 x minus 1 to the first plus a2 x minus 1 squared. Now, condition 0 says if I plug in 1 to both the line or the parabola and the function, I should get the same value. So if I plug in 1 here, every term that has an x minus 1 is 0. So plugging in 1 gives me a0. Plugging in 1 to the function gives me 1. So I know the first coefficient. Okay, property 1, the derivatives. So the derivative, y prime, is equal to a1 plus 2a2 x minus 1 to the first. So I took the derivative of this function. The derivative of my function f of x, f prime of x, I think that would be negative 1 over x squared. So if I plug in 1 to both of these, they match. If I plug in 1 to my derivative, this term goes away, so I get a1 is negative 1. The last condition here says the second derivatives have to match. So the second derivative of my function, or my parabola, is 2a2. The second derivative of my function, that is 2 over x cubed. So if I plug in 1 to this parabola, the second derivative, I get 2a2. If I plug in 1 to this second derivative, I get 2. And so from that, I can deduce that a2 has to be equal to 1. So now I'm ready to write down my final answer. My parabola is y of x is a0, which is 1, plus a1, which is negative 1, so negative 1 times x minus 1, and then plus a2, which I found is also 1, times x minus 1 squared. Okay, wonderful.